So first of all, why should we actually be patching software? I think this is a question most of you could answer yourselves. But really, we're fixing bugs in software, so every software will have some sort of bug somewhere. There are different types of bugs. Some of these are just issues with performance, and others could be that the operability of the application is affected. Usually in these cases, the patches that are released for these problems, there'll be non-critical patches. In some cases, it could be that the performance issues are that big that they will create a critical patch. What we're really interested in is the software vulnerabilities. So most applications, they will somewhere have some sort of vulnerability. This means there is a bug in the software which can be used by an attacker to gain access to systems, accounts, and data, all this sort of thing. So these issues, these security issues, should be fixed as soon as possible. And usually this will be a critical patch that's issued to fix that problem. In 2012, 70% of malware activities were based on zero-day attacks. We'll look go into a bit of depth about zero attacks in a minute, but basically, if you have a zero-day vulnerability, this means we have no protection against these attacks. Probably in the year 2015, the figure will be about the same. We'll still have about 70% of malware activities that are still using these vulnerabilities, using zero-day attacks to gain access to systems. So let's first of all have a look at a zero-day vulnerability. So here you'll see a timeline. This timeline, it may just be days, it could be weeks, months, or even years. And also the times between the points in this timeline, it could also vary from days to actual years. So what happens is, first of all, a vulnerability will be introduced. This might be by means of installing a new software that contains a bug. So you install the software, you've introduced that vulnerability into your systems. Or maybe you already have existing software that you update, or you install a new version. And installing the new version could also be installing new vulnerabilities. So what the hackers, the virus writers, the internet criminals are doing, they're actually looking at new versions of software, or even older versions of software, to find these vulnerabilities. Once they found these vulnerabilities, they will then be creating an exploit. And with this exploit, it will probably give them access to that system. It's not only the criminals that are looking for these vulnerabilities. Of course, the software vendors will also be looking for bugs in their own software, and they even pay bonuses or bounties to organizations, to other people, to look for these vulnerabilities or bugs. So really, it is a race against time. Who's going to find this vulnerability first? Will it be the hacker, or will it be the software vendor? If it's the hacker, as I said, he'll create an exploit to use this vulnerability. On this timeline, it's saying the exploit is released in the wild. That gives the impression that the exploit will be distributed to maybe lots of people, lots of internet criminals, hackers, virus writers. This isn't always the case. It could be that a virus writer, for example, finds a vulnerability and he might keep it to himself. If he knows how to exploit this vulnerability, and for him it could mean that he gets a lot of financial gain from it, or he can steal data using this vulnerability, he may not want to pass it on to anybody else. So released in the wild means really all All there is that an exploit exists, is existent for this vulnerability. And as I said, the vendor will also be looking for these vulnerabilities, and at some point in time the vendor might discover it, or someone else might discover this vulnerability and report it to the vendor. The vendor will usually then publicly disclose the vulnerability. He'll tell his customers about it. This isn't always the case. Sometimes a vulnerability might be discovered, and if the vendor actually publicizes this, it might mean a loss of image to him. It might frighten customers to know that there is a big security leak within the software. So usually it will be disclosed. Sometimes the vendor might actually keep quiet about it. So what we have now is, between this time when the exploit was released in the wild and the vulnerability being publicly disclosed by the vendor, this is the period where zero-day attacks can take place. So these exploits can be used, and at this point in time there is no defense against them. However, when the vendor publicly discloses the security hole, it could be that there are methods to actually prevent these attacks. It could be, for example, that the vendor recommends that certain services are stopped, that certain ports in the firewall are closed, or access to certain websites are also blocked. So at this point there might be a certain amount of protection. Shortly after the disclosure, the antivirus vendors will probably have signatures to actually detect this vulnerability and remove it. However, this isn't always the case. So there will be vulnerabilities or exploits that they might be able to be detected by a virus signature, but the virus signature cannot actually remove that exploit from the machine. So you're getting a bit more protection from your antivirus, but what you really need is the patch to actually fix this vulnerability. So the vendor will, at some time, release a patch. However, this patch is of no use to anybody until the patch is deployed. I mean, we can talk about Conficker. I don't know how many years Conficker's been around, 5 years maybe. Conficker is still infecting machines because even though patches are available to prevent it, they haven't yet been deployed. So this is the period of the follow-on attacks. And together we have a window of exposure. And as I said, this could be days, months, or even years, from the first point in time when the vulnerability was introduced to the time that a patch is deployed. So what we have to do is try and reduce the size of this window of exposure. However, there are a few problems with this. First of all, any application can contain a vulnerability. It's not necessarily operating systems, it's any application. Especially perhaps in smaller businesses where they have specialized applications, these vulnerabilities may never get detected. It's usually the vulnerabilities in software that is widely distributed that are detected first. So companies using specialized software, they might have vulnerabilities within that software, and the danger is here that only maybe a hacker who is trying to access a particular company may be the only one that knows about this vulnerability. All of the applications, or most of the applications that you have installed, do have some sort of application updater. So you'll have your updaters for Firefox, for your Java, for your Adobe, for your antivirus software. If this isn't centrally managed, what it means is that the user will have to decide if an update is performed. And you've all seen them, these pop-ups you get up saying that there's a new version of Adobe available. Some people will just click it away, some people will actually update. The user doesn't really know whether he should update or not. As I said, it might be just a normal patch, it might be something that's not very important, might just be an improvement in performance of that product, but on the other hand, it might be a critical patch that has to be installed, and the user usually just doesn't have the knowledge to know whether the update should be performed or not. This is usually the system administrator may have this knowledge, but if you have no central management system, it means that the administrator has to go to every single machine in that company and perform the updates. And of course you can imagine that this will take up an enormous amount of time, and of course updates will get forgotten about. And even if they have all been updated, without any sort of central management, the status of the updates for all of those PCs in the network will not be known. So the solution is really to have a centralized patch management. And GData's patch management does provide this central management, and it's also providing patches for widely used operating systems and applications. So we're not just providing patches for Microsoft applications and operating systems, we are also providing patches for many widely used applications. So to the patch manager itself, this is an additional module that can be added to any of the business products. So if your customers are using antivirus, client security or endpoint protection, they can add this patch management module very easily. All that happens is the customer orders the additional module, the patch management. When we receive that order, we change the product that is associated to that license key in our database. So we'll change it, for example, from antivirus to antivirus plus patch management. The next time that the customer downloads his virus signatures, the module will be activated. This means there's no need to install this additional module. The module is already available, it just has to be activated. Together with our technology partner, and this is Lumention, we are providing more than 15,000 tested patches and full installers. The full installers, they could include anything from complete service packs, cumulative updates, or even installation packages. For example, there are packages within patch management for Adobe Reader, Adobe Flash Player, and this sort of thing. The patches also include updates for Java. So this is one thing that has to be updated fairly frequently, so the patch management should relieve you of quite a bit of work because it will update your Java. The patch manager gives you the ability now to complete the complete patch management lifecycle. As you can see on the right hand side, the various steps of the lifecycle can all be covered with the patch management. So let's look at the steps that we have to go through to complete this life cycle. The first one is to update the vulnerability details from the vendors. So we've activated the patch management module. You'll see here that we now have the patch manager tab at the top. When we click on this and then onto patch configuration, you will see a list of all the patches that are provided. After activating the product, it might happen that this list of patches is not yet available. The management server has to update this list, so it may even take up to an hour until the patches are visible within the system. The other thing that you have to be aware of is that the filters, that is the, I'll just highlight them so you can see them. These filters here, for example, they may have already been set. If they're set, these filters will appear in black. The problem is the difference between black and dark grey isn't very visible. So you might not see that filters have been set. And of course, if filters have been set, they might be filtering out all of the patches. So to make sure this is not happening, on the right side, I'm afraid you can't see it on the screen, but on the right side of this bar, you can reset all of the filters, which I would advise you to do. Once you have reset the filters, then you'd like to have a better overview, because once the filters have been reset, you'll have a big long list of 15,000 patches, unsorted patches. So it is a good idea to start sorting, and you can do this by dragging certain columns up into here. So we can group it first of all by the vendor, and then, for example, by the priority. So I'm interested in a certain vendor, I'm interested in perhaps the high priority patches, and I'm perhaps only interested in certain release dates. So I can group all of these patches by dragging the column title up into this bar here. And of course this is flexible. You can group those patches how you want to see them, how they want to be visible to you. If you sorted by vendor, for example, you can then expand the list of patches for that vendor. And I've done this for Adobe, and you can see here all of the patches that are available from that vendor. It's also giving you the priority of the patches. This priority has been set by the vendor himself. So you'll see you have a normal priority and you'll have the high or critical priorities. You can, however, change the priority yourself. So for example, there's a certain patch you'd like to change it to a high priority. You can do that from this window. It's also telling you whether it's a patch or a full installer. So we've got a list of full installers, and here at the bottom we have a patch. You can block patches. If there are certain patches that you do not want to be installed on your network, you can block them from this window. Also, this is the release date of the patch and a license URL. If you'd like more information on any of these patches, if you just right-click them, a window will pop up and it will give you more information. As you can see here, you can see the patch hasn't yet been distributed. I just see you've all lost sound again. Can you hear me now? Okay. How long did you lose the sound for? Was it just, I think it was just 2 minutes or so? Okay, 10 seconds. So I don't think you missed much anyway. So now we have to scan the network to see whether these patches are actually applicable. So now we've filtered out the patches that we are interested in, and we're filtering using this grouping method by dragging the title of that column up into the gray bar, and by setting the filters. So here you can see that this filter has been set. As I said, when a filter is set, it is black. When it's not set, it's dark gray. So sometimes it's not really visible if a filter has been set or not. In the next version, it will be more visible. Anyway, so you've now grouped and filtered out the patches that are of interest to you. And once you've done this, you can then right-click any of these patches and this menu will then open. In this menu, first of all, you have the ability to check patches for applicability. What this means is that even though these patches are available, it could be that they are not applicable for certain systems. For example, this patch may only be for a US or English application, and you have a French application installed, so that patch might not be applicable. Another reason could be that the patch is already available on that machine. It's been installed beforehand. So that's another reason it would not be applicable. And we can check on this. You can also install patches straight away. So now you've filtered out the patches you want, and you can go on to install patches and install them. The danger is here that even though the patches have already been tested, they haven't been tested on your systems. So before you install patches, it always makes sense, first of all, to check for applicability. And then if you do want to install them straight away, then I would create a test group within that console, and I'd move a couple of reference machines into that test group and try the patches on those machines beforehand. As I mentioned earlier, we can also block patches. So if there are patches that we don't want to install, then we can block them. So we, in this case, will select check patches for applicability. And once we've done this, this window will open up. You can give this job a name. For example, we want to check Adobe Air for applicability. You can select when it should be installed, immediately, or you can plan it just to do it once, or an hourly, or whatever. Then you can select the machines that the patch should be installed to. You can either select all of the machines in the network, or you can just select single machines by opening up the visible groups. So once you've done this, an applicability job will be created. And you'll see this in the task section of the management console. And you just have to wait until this job has been run. So after these jobs have been run, then we can move on to the next step of the patch management lifecycle. And the next step would be to identify the vulnerable systems. So up to now, we've created an applicability job, the applicability job has run. And now we can move to the status overview. And this is now giving us a status of these patches. You can see at the bottom that we have patches that have been installed. We have patches that have been installed, but a restart of that PC is required. We've got a lot of patches here that are not applicable, patches that are not yet installed, and also a status unknown. The status unknown means that an applicability job hasn't yet been completed for these patches. After it has been completed, the status will then be changed to one of the other four: installed, restart required, not applicable, or not yet installed. What is really interesting to us is the patches that have not yet been installed. And here we have patches with normal priority and priority high or critical. So once we know this status, what we can do is to then move on to the next step, and that is to download and deploy the patches. So here we've got, in the status overview window, we have the patches that are not yet installed, and we selected one of the patches that has high priority. So I can select one of these patches, or I can select multiple patches and I can install them. This means that a task is then going to be created again, a software distribution task, and you can give it a name and again plan when the task should be run. Here again, a task will be created in the task section of the console, and it will also give you a status of that task. So after creation, it will be waiting to execute, and if you select it immediately, after a couple of minutes, then that task will run and it will report back a status, and it will show you that that task has been completed. So now we've looked at the patch configuration button and the status overview button. So to sum it up, the patch configuration button, all it's doing really is just listing the patches. You have to plan and sort these patches according to the patches that interest you. So using the grouping methods and the filters, you can select which patches are of interest to you. You can create an applicability job. Once the applicability job has run, you'll see in the status overview what should be done with that patch, whether it should be installed, whether it's already been installed, or whatever. So this will be in the manual mode. So you have this manual mode of installing patches. In this settings window, you also have the possibility to enable patch management or disable. There might be PCs within your environment that you do not want patches installed to for whatever reason. For example, developers, they might have machines with administrative rights, and they decide themselves whether they want to install certain patches or not. For example, rolling out .NET Framework to a developer's machine might be, I wouldn't say it's fatal, but you might upset your developers for some reason. It may be that he doesn't actually want this patch to be installed. So for those machines, you can actually disable patch management. The second one in the list is to automatically check the patches with high priority for applicability. If you're only interested in patches with high priority, the critical patches, then I would recommend that you actually select this, because this will mean that it's taking one of those steps away. So it means that there's less work for you to do to check the patches for applicability. So when a patch is released and the management server has been updated and that patch is available in the management server, it will automatically test straight away whether it should be, or it'll test straight away whether that patch is applicable. And it will give you the status in the status overview window. It's also possible to install patches with high priority. You can also do this, and really this will be, you could say it's a turnkey system for your critical patches. You could just activate this and not worry about it. So the system would actually install all the patches with high priority. The danger with this is, as I said beforehand, before you roll out patches, you should actually test them. So this could save you a lot of work, but on the other hand, it could also create a lot of work. It might be that you have some PCs that are blue screening after installing certain patches. So really what I would recommend is that you actually manually carry out the patch applicability job, because this, if you're carrying out these jobs manually, you can also check the patches that have a low priority or normal priority for applicability. So this is the settings tab, and these are the different options that you have. So the last step we have to carry out is to generate a status report to see what we've actually done, to see the status of the network. Without being too critical of the software, I would say that this is the weak point in the patch management. At the moment, I don't believe that the reports that we can create are giving you the right or enough information about patches being that have been installed, when they were installed, who installed them. I mean, this is useful information for auditing purposes. And at the moment, this isn't available. Feature requests have been passed on to product development to actually improve this in the upcoming versions. And here, this is where we'd like feedback from you. So if you are actually using the patch management, or you're thinking of using it, if you can see any of these weak points within the software, please pass us on this information. And if you have a feature request, we'd love to see it. Anyway, within the business products, we have the report manager. In that report manager, we can create new reports by clicking on the green plus button. It will open a window where you can give the report a name. You can select the language you'd like the report to be in, and also the recipient groups. Who should this report be sent to per email, and how often should it be sent. After you've configured it, you can then select New, and it will open the module section. So here you do actually have a module for patch management, where you have pre-defined reports for Patch Manager. You can select just a single category, or you can select, a single report, or you can select multiple reports to be included in a combined report. You can define how many the number of lines that should be included in the report, what the output should look like, table, bar chart, 3D chart, etc. And also select the period that should be covered. So once this has been done, here is just an example of one of these reports. So this is a combined reports where I've included several reports into one report. As I said, you'll find in a lot of these reports there is actually no mention of which machines the patches were installed to or when they were installed. And this is something that should be included, and I hope that it will be included in future versions. Let's just summarize on what we've been through and a couple of other points that are maybe of interest. So if you do actually have internal policies, which I'm afraid a lot of companies don't actually do have, relating to patch management, it makes it a lot easier to actually comply to these policies. In a lot of countries, especially like the USA, there are a lot of external requirements that you have to adhere to depending on which industry you're in. And of course, patch management will make it a lot easier to comply with these requirements. There is reporting, as I've said, it could be better, but it should be able to show you the security posture of your network at any period for any period of time. One of the problems with not patching systems on your network is that it comes to an unsupportable state. For example, there might be patches to improve the performance of an application, for example, or to correct a small operability bug. If they're not patched, it probably mean that the IT staff have to be involved a lot more in maintaining these systems, especially if they are security bugs. If they're not being fixed, this means that you've got an open gateway to viruses, for example, and these viruses could be causing a lot of damage, which means that the IT staff have to get involved in support again. So it would be taking up a lot of time, or a lot of the IT staff's time. And over a long period of time, it will mean that these machines perhaps do become unsupportable. The most interesting thing for us is to keeping up with the security updates. As we've seen in that life cycle of a zero-day attack, antivirus solutions may detect certain exploits, but it's not until you actually deploy that patch will that gap be closed and you will have complete protection from that exploit. So really this means that you could use patch management without antivirus, and as we saw that 70% of viruses do actually use exploits. So if you're just using patch management and you're keeping your patches up to date, it will mean a lot of these viruses, they may infect your systems, but they can't actually do anything once they're on their systems. But on the other hand, if you just have antivirus, you may or may not be detecting some of these exploits. A lot of exploits might be detected, but there will be exploits that get past your antivirus. So if you have both solutions in place, your antivirus will pick up most of them, and the rest that do get through, they won't actually be able to do anything if your systems have been patched. And we've seen that our solution also provides patches for third-party applications. There's quite there's a couple of solutions out on the market. They say they're patch management, but all they can do is actually just deploy Microsoft patches. But as we've seen, we do have a lot of vendors that we are providing patching for.